So what is a derivative? A derivative is the slope at a particular point. So what happens if we don't have a graph, we don't have the function, but instead we have some numbers? That's kind of like real life math, where are set with a big data set of numbers and we got to figure some stuff out about it. So what are we going to do? Well, we know derivative is slope, right? So your best way to approximate given a table would be to use the slope formula. So if we want to approximate f prime of 9, we probably want to pick 2 points as close to 9 as we can and find the slope of that. So where would 9 be? 9 would be right there. So what I'm going to do is I'm just going to use these 2 points there and find the slope. So we have the point 7, negative 89, and the other point 10, negative 99. And we'll just do y2 minus y1 over x2 minus x1. So negative 99 plus 89 is negative 10 over 3, which would be about negative 3.33. And that's the idea. There's a bunch of different, I'm telling you, there's a bunch of different methods for numerical estimating derivatives. A lot of them take computers though. And so we're just doing the basic, find the slope, and go with the closest answer that you can find. I know that 9 is actually closer to 10, so usually there would be some sort of way that we can weigh this a little bit more, the negative 99, than the negative 89 as far as the slope's concerned. But like I said, for us, for what we're doing, it's just know the concept, the idea that slope is, the derivative is the slope. So if they ask you for the derivative of a table, just try to find the slope as close as you can to that point, and that'll be good enough, at least for AP Calc. It's more when you get to like the computer-based, applied math, that you're going to have to get something that's a little more accurate. F prime of 4, honestly, it's right in between here, perfectly in between there. So that would just be 112 minus 95 over 5 minus 3. Put that in your calculator, and whichever number comes out the closest. So that one's pretty easy to do. Right here, what's the best estimate for h prime of negative 18? So once again, what's the derivative at negative 18? Just a different way they can ask it. So that would fall right in between here. Like I said, it's a little closer to negative 17. So there's a way we can weight that more in some other formulas. But we're just going to make it simple. Find the slope between those two. So that's going to be 17 over 3. 17 divided by 3 would be a little more than 5, right? So probably this one. What about at an endpoint? So negative 1 falls right here. Negative 1 is right there, right at the end. So we're just going to use the other point next to it as close as we can to it. So it's just basically use your brain in a way. I hate to say it. I don't mean to be rude by that comment, but think about it. If derivative is slope, how would you estimate that? So 45 minus 53 is negative 8 over 2, which would be negative 4. And that's how you would estimate the derivative given a table.